Okay, so the first to give you some introduction, I prepared another repository for this tutorial. The tutorial is about Docker in research. You should receive a link with some information that I will be sharing with you today. Hopefully, I will give you some more background and more information during the seminar, but it may be useful for you to at least have the README file in front of you. So this is at my repository this time. The last time was on your repository, but this time it is on mine. Starting, this seminar actually has two names. One of the names that you know is Docker in research, and the other is Docker for beginners. This is because I assume that you have not used Docker before. We will be going through some basics of Docker, because I think that for researchers and for the purposes that I would say people other than professional DevOps use Docker, you need just a beginner's knowledge. Actually, you can go really far with Docker. You probably know that it is very frequently used in really big companies as a way to scale up servers, but this is not the case we will be talking today. Just by starting, I will assume during this tutorial that you are using a Linux-based system, preferably something like Ubuntu. You can also use Docker from Windows, but it is a bit more cumbersome. Still, the installation is on the website, so on the Docker website. In my README, you have the links. Also, in the repository, I created a simple file for installing the current version on Docker on Ubuntu. Although for future, I cannot recommend using this, for example, a month from now, because there may be a chance that people from Docker changed the way that it is used. Just to maybe I will show you the file itself for the installing. So let's maybe switch the screen. So what you need to do to install Docker on Ubuntu system is to run these commands. The most important commands are the ones connected to Docker. So the one this command will download a script. Actually, it is keys for the script, and then this command will install Docker. But actually, the Docker, the community edition. So there is also a professional edition, paid edition, but we will be using the community edition. Also, there are some other steps that I assume that you did. They are very frequently done on the Docker system. First of these commands adds a group called Docker, and then the second command adds the current user to this group. This is so that you don't need to use sudo in front of each of your commands. Normally, if you do not run these two commands, so this group up, the user mod, and then actually you have to log out and log in back to the system, you will need to put sudo before each of the Docker commands. I find it super frustrating, so usually I put these two commands. But all of these commands will make you capable of running a Docker system. For Windows, there is just an installation that you have to run on the Docker website. So this website, you have the instructions for Docker for Windows. You just need to run through the commands, and it guides you really well. So I will not do this now, especially that I actually don't have a Windows system. So I assume that you did it. If not, maybe you can do it in the background while I'm explaining the first part. So actually, why use Docker in research? This will be a bit of theory. We will jump to the workshop part very soon. But first, I want to give you some background of why using Docker is actually important in research. Not only useful, but also important in research. So Docker is a system for virtualization. It is a very lightweight system for virtualization. So it is a one that you don't really need to create a whole computer inside of your computer. Virtualization, the idea of virtualization is pretty much, it means that inside of your computer, there's another system. So for example, I have a Ubuntu system and I will have something like another Ubuntu inside my Ubuntu. There are many ways to do this. The main purpose of doing this is that somehow I isolate these two systems, one from another. So, for example, my system, the one that you're seeing now, it is like a standard, maybe not a standard, but it is a Ubuntu system. And inside of the system, I have, my own files. I have my own environment. Some of the program versions are old. This is actually something like Ubuntu 16.04, so it is 4 years old. So, for example, I do not have the newest Python, which I might want to use. The other part is that, for example, I want to use something that comes from other people, but I want to make sure that it will not destroy my computer. It is quite important, right? In a big case, I don't want to worry that somebody's software destroys my computer. But this is like a general case of why virtualization is nice. Virtualization comes from the server community. So imagine that you have your server and you want to share your resources with other people. So for example, in your laboratory, there is a server, many people use it, and all of them, they want to have a different system. So instead of giving each of the users a different computer, you can give them a way to virtualize the systems that they want to use. So one person can use Fedora, the other can use Ubuntu, and so on, so on. In past, the most frequent solution was to create like a actual part of the computer, like for example, one whole core and half of RAM would become used by one person. It was a nice solution, but the problem was that it was not really best way to use resources. The way that you can check this kind of system is, for example, by using VirtualBox. VirtualBox, maybe some of you are familiar with that. It's just a way to start. Maybe I have VirtualBox on this computer. So VirtualBox. It's, for example, when I click this, actually I cannot start them because the images are no longer there. But by starting this Ubuntu 16.04 ROS, this would start just a new computer, a whole computer. It would have like a virtual CD, it would have a virtual USB, it would have a virtual RAM, virtual GPU, and so on. So kind of nice system, especially if you want to share, for example, a Windows machine, but very resource demanding. So it would demand a lot of resources, and it would be quite heavy. So for example, this machine, this Ubuntu 16.04 ROS, it is a Ubuntu with something called robot operating system. My background is in research, but in robotics, is something like 16 gigabytes. So this really huge machine just to run some software. Instead of that, using Docker, you will also have some kind of virtualization on a bit different level. Usually you have like a picture of some kind of pyramid, and in this pyramid you have something like your resources, and on the top is like a user space, and somewhere in between, you, like in case of a system like VirtualBox, you actually are very new resources, and in case of a Docker, you are very near the user space. And the difference is huge in case of your resources. It requires much less resources, and it still can be quite secure. You also get a lot of control, because as an administrator of a Docker system, you can, for example, share all of your resources, but you can also somehow limit the resources that are available for each container. What we will be using today is the idea of container. So Docker is a name of a virtualization technology, and there is something called containers. The container is actually running process or running set of processes that make a virtual computer. We will be creating today the containers, as well as create something called images. But still continuing with the motivation. So in research, in general case, it is a way to make a cheaper access to resources. But in research, the main goal is different. It is a reproducible research. So research that you can share with other people in a way that they can reproduce your research. This is the main goal of using Docker and Docker containers in research. Imagine that you have your own paper in Nature, right? And there is a huge interest in your research, and you made some calculations. And some people, for example, now it is the case of Russian vaccines, some people are really not sure whether your calculations are correct. In your paper, you created your own, you stated how you created this research, and you created that this is by calculating this in, for example, I don't know, R or Python or something like that. But people still want to really just do what you did the same way. So we are not talking only about sharing your data, but also sharing your computational environment. And this is really important in modern research. So by using Docker, you have a way to easily, and I would say explicitly, so in a way that other people understand, you can create an environment for other people to share. Also, you can use other people's environment. Maybe you are not so doubtful that you will check every paper and reproduce the research. But for example, there is a new technique. This new technique demands a whole set of software. And you really don't have time to install this software, or maybe you don't have the way how to do it, because sometimes it requires some complicated compilations. It requires downloading data from different sets. So by using Docker that some other people created, so the container that other people created, you can actually reproduce other people's machines. So you, using your own machine, have access to somebody else's machine or machine setup, I would say. Of course, the machine itself can be different. So, for example, your machine can be much more powerful or less powerful. But usually it is not the problem. Of course, if somebody says that on his machine the calculations took 6 seconds, and on your machine you have like 60 seconds, this is not reproducible. But for example, if the calculations are different, probably it is pretty much impossible, because your environment will be the same. There was a question from Mystic Mike about whether it is something like environment in Anaconda. Actually, yes. So it is very similar. The difference is that you have you can do much more using Docker. So in Anaconda, you usually can create an environment. The environment is usually something like some particular programs. But in case of in using Docker, you can set up a whole system. So for example, your system can require compiling some specific libraries, or for example, you are a fan of particular operating system that has some quirks. and you can actually create a whole computer. It is, I think, much more than using Anaconda, but the idea is quite similar. Also, because I have experience using both Docker and using Anaconda's environments to create something like environments to share, I had trouble recreating some others people Anaconda environment. And in Docker, I'm kind of, I would say 90% sure that I will have no problems. I would even say 99% sure. In Anaconda, not so much. Try, for example, sharing your particular environment for a different system. So you are using Windows, somebody is using Linux. And you will see that sometimes there are problems. In Docker, not so much. I can share my image to other people. They have their own systems. They will create containers. The containers will behave exactly the same. And this is a very powerful idea. And I would say the most important part. So hopefully this took me something like, the introduction took me something like 20 minutes. Hopefully those of you who wanted to go along have already installed the Docker system. If not, I suggest that you do, because it is quite fun to run, and we will run, I think, some nice commands today. So first command that we will be running, let's maybe see whether the Docker is there. So if you just put Docker, you should have something like that. So you should have just a Docker listed. Hopefully you have Docker without sudo, but even with sudo, so if you did not manage to actually log off and log on, you still just put sudo in front of the commands that I will be explaining. So first command that we'll be putting is this one. Let's not go too far into details of how this command works, but what is happening right now is you can see that the Docker is downloading something, and it actually downloads, you see some numbers. These numbers actually are hashes, so specific names of, or shortcuts of names of layers. So inside of Docker, there is this brilliant idea that you can actually keep parts of the computer. And if you want to add something new, you add something new on the top of a previous computer. I'm really simplifying stuff now, but you can imagine that, for example, someone created a Ubuntu computer, and then you are adding some software to it, and then some other person creates some new software on the top of that, and so on, so on. So right now you can see that we are, what I inputted here is that we are running. So we are running means that first we start, and then yeah. So it means that we will be starting a container from this image. Image in a Docker vocabulary means a template of a computer. So it is like a computer that you can copy. Container is an actual physical version of this computer. So we are using the Jupyter minimal notebook template to create a particular version of this computer. So computer, virtual computer, right? So I used this image. This image is actually from a Docker Hub. Docker Hub is like a repository for many different Docker images. And for example, people who create the Jupyter IDE, they created a set of containers. Right now we are using the minimal notebook, so it is like a demonstration of Jupyter. And it gave us this output, and it gave us this link. So let's put this link to some browser. So maybe I will start the Firefox browser. you will get a different name. Hopefully it starts. I don't see a reason why not. Oh, I see a reason why not. Okay. So by using this command, regardless of whether you have a Jupyter on your own computer or not, you now have access to a Jupyter. Probably you know what Jupyter is, but for those who don't, this is a way to, I would say, prototype software, particularly prototype Python software. So right now I can put some comments, I can do some stuff. So this is actually a Python. We can, for example, see that it is a Python version 3.8.4.5, regardless of which Python version you have on your own computer. This is a computer in a box, kind of strange computer in a box, because we are now in a directory called home and Jovian. If you are an Ubuntu or Linux user, you know that home is a place where you probably have your own directory. So for example, my username is Igor, and I have Igor there. But right now, magically, we have home and some Jovian, but there is actually no Igor. So I cannot go to home Igor. It will give you me the information that there is no such file or directory, because a typical container without some special options will not have access to my own directories. It only has access to its own directories that are inside this container. Let's put some, for example, let's install something. So for example, I can install pip install install scikit-learn. It may be quite long to install scikit-learn, but hopefully it will install. Okay, so I installed a scikit-learn. Give me, for example, sci-fi. Let's also do some stuff. The stuff we are doing right now, it doesn't really matter. So for example, we'll create a file. What is important now is that we have a file, right? And also we have SciPy. So let's close this container. To close the container, you just need to do Control-C, or sometimes you will do Control-D. Control-D is the logout command. But what we did right now is that we closed the container. Closing the container actually means that, what does it mean, right? Well, closing the container means that this computer is saved to a file. It is actually right now a file. So let's put this command once more. I put the same command once more. It may seem like a useless exercise, but it is actually not. So we are in a work directory, and it is in this work directory once again. We will put maybe not in the work directory. Let's go to the main directory. Once again, let's for example put ls, and the reason our file disappeared. There is no longer a file that we created. SciPy. Did something go wrong? Actually not. what happened is by using this command, so we stopped the container and then we did the run once more, we created new container. So right now on our computer, there are 2 containers. And one of these containers is running, the other is not running. But actually there are 2 containers. Also, maybe you noticed that the second time we run this command was much faster than the first time. It is actually because it is a new computer. So this second command created a new container, but the template for this container was already downloaded on our computer. So we did not need to download and actually compile this new template. So this template is called image. This image was already there. The only thing that was needed was to start a container using this image. And it was super fast. Compared, for example, to VirtualBox, you can create containers much faster. By much faster, I mean in a seconds or even parts of seconds. So the question by Mystic Mike was whether the scikit-learn is installed. It is installed, but in a different container, not on this one. This one is completely fresh because we used the Jupyter minimal notebook image. And in this image, there is not this scikit-learn. So in this container we are running now, there is no scikit image, and also there is no file. I put the command touch and the name of a file to create a file, but this container does not have this file. This is very important, that you have to distinguish between having an image and having a container. Container is something with files, it's something with some installations, it's something, like something similar to a physical computer. But image is something different. It's just a template. By using this template, we can create multiple of these containers. Right now, this is actually a fresh system for me. We can see that right now there is one container. It is called amazing Vue. If we put this flag, so Docker container list all, we will see that there are 2 containers actually. But one of these containers, the status of one of these containers is that it is running from 3 minutes ago, and there is a second container that died 3 seconds ago or exited. So this was this previous container. But for you to understand, it is actually like that, yes. So Mystic Mike has this comment that one is like an object and the other is like a class. And it is very similar, yes. One is like a factory of containers and the other is just a container. It is really true. We will see that from container, you can create an image. So this kind of breaks this analogy with programming, but you can create an image from a container. We will see this in later, but right now, just you need to understand that it is very different than from VirtualBox. That if I do something in VirtualBox and I stop it, I don't. When I start it again, and so when I start it, I have the same VirtualBox. But in case of Docker, by using the command run, you usually create a new container. It is quite also important to, we will see this through this tutorial, it is quite important to understand that containers are something called ephemeral. So you don't really expect that the container will last. Actually, it is something like a good thing that containers really last for a couple of minutes, seconds, or they are not something that lasts. You want to create your container in a way that you can just start it, do something, stop the container, and you forgot about this. You, for example, don't keep data inside of containers. You will see that you can do that. So going back to the question by Mystic Mike, our data is not lost yet, I would say, but it is not a good practice to expect that data inside of the container is something that will be accessible in a month or so. If you want your data to be accessible, create an image, or you will see later that you can, for example, share your data with your main system. It is a good practice, much better than keeping in container. Okay, so this was our basic example. The basic example, the motivation was for you to see how easy it is to start a container. Right now we have two containers. I cannot really start the old container while the old one is running. This is because when I created this container, so for those of you who understand the Jupyter, what the Jupyter does is that it does his Python thing, but it also has a server, and this server is running right now on a port 8888. But actually, because the Jupyter is running inside of a container, we had to put a special flag. So in this command, there was this special flag, -p 8888 8888, which means that please share the port that it is inside the container 8888 to the host computer on the same port. So if I try to run the old container, so actually to start the old container, there will be a conflict because two containers will try to use the same port. So I will first stop this container. So I'm still using Control-C. I'm stopping this container. On my list, right now I will have that the two containers stopped. And now is the kind of strange part, because to start the old container, we'll put command document-container start. I will put another flag. This time, this will be AI. The AI is actually not artificial intelligence, but it is attached and interactive. And I will put the name of the container that I want to start. So running means use the template and create the container. And starting means take the container that it is already there and start it. But I need to know the name or the ID of the container. So I can use the container ID, which is not very beautiful. I want to use the old one, but I can also use the name. And I don't remember that I put admiring Spence or that I used amazing Vu to create the container. And this is because if I do not put a name flag, then name will be random. So we will do it later, but normally the name of the container will be created automatically. So right now I will be starting the container called admiring Spence. Was it admiring Spence, the older one? I think so. So this is the admiring Spence. Let's put again the address. I have the untitled, and let's see whether there is a SciPy installed. Yes, there is. So the whole point of this example was to show you the difference between image and container and to show you run. But my largest motivation to do this, actually to give you motivation, is look how easy it was to install Jupyter. You did not need to install Anaconda. Anaconda is something like 0.5 gigabyte. Imagine that you want to share your Anaconda and your Jupyter environment with somebody that is kind of skeptical. You have a friend that is interested in programming, but he doesn't want to, commit to installing the whole Anaconda. You just need to share this container. Actually, this container was not 500 megabytes. It was something like 23 megabytes. You can see it. You can see it somewhere here. Normally, when the layers are downloaded, you can see the size of the layers, but the layers of Docker system are quite small. Altogether, it would be probably something like 30 megabytes. So also for those of you who understand the sizes of Ubuntu, Ubuntu is actually a couple of gigabytes. How it is possible that here we have a couple of megabytes, maybe a couple of hundred of megabytes? This is because the Ubuntu that is inside of this container is very small. It does not have most of the options that normal Ubuntu has. Of course, it doesn't have a graphical environment, for example. Okay, so this was the motivating example. And the motivation, so right now we have this reproducibility. I think this is the most important part for researchers. And the second motivation right now is laziness. You have a computer in a box that maybe somebody provided. So let's be optimistic, and maybe we can find some nice, useful Docker images. So one way, the way that I usually do it is by just putting. So, for example, I want to find. I'm interested in Keras, right? So Keras is for machine learning, for deep neural networks, but I don't want to install Keras. I put this, and for example, I find TensorFlow environments for Docker. I also have the whole environment with GPU and Jupyter. It is just one command between me and Jupyter with TensorFlow installed. So this is what I do. The other way to find these containers is by using the Docker Hub. I find it kind of difficult. I will show you why. So instead of doing the Google way, we can go to the Docker Hub. Docker Hub is one of the repositories. One of the repositories, actually, I am not logged in Firefox. So maybe let's use Chrome. No, I'm not signed. But anyway, we have a search box here, and we can put the same command. So Keras, or Keras, just Keras maybe. You will see that you don't really have a nice way to. It goes through the most popular, but I don't really know what most popular means. I really suggest you that if you use Docker Hub as a way to search for containers, look, for example, what was the last time something was updated. If it was updated 3 years ago, it means that it is dead. So at least try to go to recently updated, but also you'll find that, for example, the number of downloads is quite poor. So I do not actually recommend to use Docker Hub search to search for environments. It is much easier to just use Google and be kind of resourceful doing this. There is actually some other containers. So, for example, you can find whole sets of tools, like, for example, data science containers. We can start this one. It will be actually quite similar to the minimal one. So if you don't want, you can use the minimal one. Just for you to show, right now I will be putting some different flag. So we will be using Jupyter Data Science Notebook, but I'm putting another flag, name, and this will create a named container. So named container means that it will not have a random name like amazing Woo, but it will have like for example, my data this is something like that. So you can notice that many of the layers already exist. So on your computer, it will the system, Docker system, will not download all of these layers because most of them are already downloaded. Still, it is quite big, so it needs to download something, but not all of the layers. Okay, so we have another question. When I run programs from the containers, the resources I'm using are those of my computer. Yes, true. When it requires GPU and you don't have a GPU, you have a problem. Normally, in this case, especially TensorFlow, please use the TensorFlow without GPU, and it will just use CPU environment. Actually, in this case, you can, for example, use some virtual computers in cloud. They don't necessarily need to be computers on your own box. It is also very easy to, for example, just rent a computer and put a Docker there. Sometimes on some services, you don't even need to put these commands. You just state which container you need to run. So this is my recommendation. If you want to play with GPU, for example, Paperspace has a nice GPU systems. I run containers on Paperspace with Docker there, and it behaves quite nice. But of course, if you don't have resources, you don't. It is not like a magic, right? Also, I want to give you a tip that actually with the graphical cards as well as your screen and so on, you need to give access to a container. Normally, a container will not have access to your GPU. It will only have access to your CPU, and also it will have a very limited access to your file system. And in case of Ubuntu or Linux systems, normally some directories are necessary to access to devices. So for example, your container normally will not have access to your USB camera. You need to provide this access to a USB camera. I will not go into details to that, but normally it is very easy. You just need to specify a shared resources by a flag. Usually it is a volume flag, sometimes it is another flag, but by standard, containers are quite blocked from accessing your physical devices. So devices like camera, devices like GPU, or devices like, I don't know, printer, for example. So we downloaded the new machine. We have the new URL. It should be a bit more powerful container. So hopefully this one. Hopefully this one has. You can see that, for example, this one not only has Python, but it also has R and it has Julia. So it is, I would say, a more powerful container. But let's stick to Python. We will just see that, for example, this container already has SciPy. So it is a container that, for example, you can use as a basis to something more interesting. Imagine that you want to create new software, or you want to compute something, and you are working from your friend's computer, right? And he doesn't have anything installed. So you just need to download this image, run this container, and now you have a powerful system. Still, there is a problem inside of this system. So it is really nice and so on. But the problem is that what do we do with the results? Where the results come? So I have a file, right? This file is a file, but where is it? How can I download this file? Actually, it is not on my computer. So in this folder, I started this container here, but this file is not here. Right now, by just running this command, you will have a difficult time to get this file other than sending it from the container. So for example, I can use some command like the easiest one would probably be, for example, download as, because this container is a separate computer from your own. It is a good thing, because imagine that you have a container that contains some nasty stuff. So somebody created a container that has a command like something like that, right? So destroy all, right? This command would sometimes crash your computer. But inside of the container, nothing other than destroying this particular container would happen. You need to specify that you want to have a shared resource between the container and your host computer. To do that, let's close this container, because really you don't have a good way to do it after you create a container. This container is somehow lost. So first, let's close this container. The second, you can see that I'm using this command docker container list. And right now I have these 3 containers. I can actually remove these containers. Each of these containers is actually keeping some of your space. So you can put something like docker prune. Prune would mean that you remove all of the containers that are not running right now. I do not recommend this command because sometimes you still have some interesting files inside. So you can run docker container and just remove particular container. Maybe even remove. I think it was RAM. So you can just remove one after another if you want, right? Because they do keep space. I managed to make my computer full of containers. So right now I'm doing some specific trick. This trick is actually, I think, in one of the screens. But what I'm doing right now is that I have a specific folder. It is not my main folder when I keep my container. Right now I'm running the Docker service from a different directory. It is not really necessary, but normally at least some people have not quite limited space. So it is sometimes a good idea to have a special directory for containers that is on some big disk. In my case, it was like a 6 terabyte disk. But let's go to the main commands. So the main command that we will change. So first, let's maybe we will try to see. As a warning, we will have an error. So right now, expect an error. So what I'm putting now is a flag called volume. This flag volume states that I want to share some files between the container and my host system. The PWD means current directory. And in this current directory, for example, on my computer, I want to, wait a moment, I want to share my research folder. So PWD, my research. And after this, I need to state where I want this folder to be on the in the container. So it is quite difficult because I forgot the name of the user on this computer, so I will just put it on the root folder. So this command should not work. It does not work. This is because there already is a container, my data analysis. So I cannot create two containers with the same name. First, I need to remove this my data analysis container before starting new one with the same name. Okay, so before running this command, maybe first let's start this command. Although we will have kind of difficult time to access this my research folder. But let's start it anyway. You can also see that this computer is accessible through different addresses. Normally, if you start Jupyter on your own computer, this would be a place with the external IP, and this would be a place with internal IP. This strange IP is because Docker provides you with a way of creating these IPs, but it is quite complicated one. So let's go here. And unfortunately, I think we were in the home Jovian, but still we can, for at least the root folder, and look that in the root folder there is a directory my research. So maybe because I'm quite lazy, let's create this old folder here. So let's put it here. Okay, so right now I will be sharing my research folder, and inside the home Jovian my research. So once again, it will not allow me to do that. Actually, if you want to do this and you don't care whether after stopping the container is still there, so you want to create this ephemeral container, so the one that's after stopping it disappears. So after stopping you no longer have this container. You need to put flag minus rm. You still need to remove this container. If I put this minus rm, after I close this container and start it once again, it does not give me error, because after I close this container with this flag minus rm, it removes the container. You may say that it is kind of silly, because why would I want that? But actually, I use I am machine learning expert in a company, and all of the containers that we run there, we have these ephemeral containers. So we don't care what happens after they're closed. We expect them to disappear. But once again, let's put this address. And right now I have folder my research. And what is nice that if I put a file here, so let's create a Python file once again. So I have right now permission denied. And permission denied is because actually the user, yeah, it is quite nice that we have this problem. So my research, so right now I'm on a host system, and if I put here the permissions, actually all of the users should be able to do something with my research. That's kind of interesting problem. It's quite interesting problem. Permission denied. we are not allowed to create something there. So it means that the user of this system does not have access to this folder. He cannot create, does not have right permissions to this folder, which is kind of interesting, but I can add this. This will solve it. No. That is too bad, actually. Permission denied. Yeah, that is kind of sad. Okay, let's stop this once again. Sorry for that. But this will allow us to a bit. What I'm doing right now is that I'm trying to give myself permissions. So give all of the users permission to write inside of this. But somehow I am failing. So right now I gave myself all of the permissions. 777 is somehow a hack to give myself all of the permissions. Hopefully this will solve the issue. There was another question. How does machine just allow it does not allow me to use the same port all of the time. I need to close so the question is, I don't know if you can see the question, but the question is how can I how many different programs can use the same port? They cannot. The only time I can use this port by multiple devices is when I stop the previous container. I will show you a workaround around this, but normally only one program can use one port. But so the previous containers are closed before I open the new one. Okay. Hopefully this works. No, I still have permission denied. That's very interesting. Why I have permission denied. Okay, maybe I will figure out it a bit later. What I want also, we can use this opportunity to somehow access this container through a different way. So right now we have a running container. So we have this my data analysis container. We have that this container was started a minute ago. We can also see that it has access to port 888, and it is sharing this port with the host system. And what we will be doing right now is that we will access the same container from a different terminal. I'm now putting command docker container. Now it is execute. Now I'm putting a flag interactive. Now I'm putting the name of the container, and execute means that inside of this new container, I want to run some program. In my case, it will be bash. So what happened right now is that I am inside of this container through a different terminal. So I'm also checking my research folder. it actually has a different permissions. I kind of forgot how to there is also a flag to do that. What I'm doing right now is I will try to that's interesting. So actually this computer has a user and it also has a password on sudo, so let's maybe skip this particular example. We will come back to this example, but I need to remind myself how can we do that. Let's put some different commands. So we did the command remove. -v means that we share resources, particularly we share volumes. There is also a nice command called log. This is more used in a case when you have a container running in background. Why would you run a container in background? For example, you want to run a server from your own computer, or maybe from your own, even Jupyter is a server, right? So imagine that you want to give access to Jupyter to different users. And to do that, you will do it in background. And so you will not be putting the interactive flag, but just running these containers in background. So in this case, it is quite important to know whether there is, for example, something bad happening. For example, I had a container that every 5 minutes required restart. There was a flag that it restarted automatically. So every time it stopped, it started again. This was very fast, so there was not really issue about short processes, but you can imagine that, for example, if calculations took a long time and it restarted, it was quite problematic. So I'm now putting command docker container log, and now my data docker container, maybe even some docker container log, docker somehow logs. Sorry, docker container logs. Okay, it was not log, but it was logs. And by using docker container logs, the normal output of the container will be presented on this screen. This is actually a log that also can fill your computer. Yeah, if your container is very talkative, this log can be quite large. But right now you can see that, for example, it gives us this forbidden information because this folder is not accessible by the user. So we could somehow debug this by using this command. Okay. So there is also another use of the containers. It is quite similar to the one that we are using right now. But actually, containers can be used as a way to just run a program. So, for example, there is a whole set of containers called biocontainers. Biocontainers, it is just an effort of a group of people to give. It's called biocontainers community, and they give you a whole set of bioinformatics containers. So there is such a large number of tools inside of this that are already installed. So they have this nice example. I took this example from their own website, that you can use a container as just a way to start a program. So for example, you want to start a BLAST program or BLAST-P program. And instead of installing and so on, you just put this one command. In this case, it's kind of silly because we will be starting blast command, but with just a help flag. Anyway, let's do that. As you see, it requires us to download a lot of layers, so there were not too many similar layers with the previous container. Actually, the previous containers was kind of tricky because normally what containers do is that they when you share normally inside of containers there is only root user. It is good practice to have a container with more than one user. So in this case, this Jovi or Jovian container had this special user, but as you see, it is a bit more tricky. Okay, right now we are downloading this via containers. And what happened, so maybe let's put the rm flag, because every time I run this command, a new container will start and the previous one will be still there. But this command just gives us the help for this command. So this is like a way of using containers to just use some software. Inside of the bio containers, there's plenty of software to choose. Actually, you even have like access to Bioconda. I recommend you to read this. No, it would not be slower. And some Mystic Mike question is whether running something inside of the container makes it slower. It does not. You do not have performance penalty by using container systems at all. This is a big difference between using containers and using VirtualBox. Inside of VirtualBox, you do have quite a large penalty. Here, you do not. If there is a penalty, it is a bit when you are starting. Of course, some of your resources are used for the system, so you get a bit of less RAM, but it is really marginal, so you don't need to care. There was to connect this to a previous question. So the previous question was whether you have access to GPU and so on. Also, you get like such a marginal penalty that I would not care. So yes, it is actually quite a good way to also coming from this reproducible research. Imagine that you have the system, and for example, it gives you good results with version 2.31, but bad results with version 2.4, for example. So what you can see actually here is the name of the repository, the name of the image, and after this sign, you have a tag. So actually the whole part is a tag. You want, in case of reproducible research, you really need to use tags. So you need to specify a particular version of the software you want to use, because otherwise you will get strange errors that, for example, oh, I got the result 1.4441, and on a different version I get 1.4442. So what happened, right? And when you keep the same version, you are pretty much guaranteed to have the same result. Of course, if something is deterministic. So actually, what I use this kind of commands for is that, for example, you can experiment with new software. So right now there is Python version 3.9, and for example, I can already experiment with this version. So let's start Python version 1.3.9 by using this command. So I'm putting this command. This command, once again, it shares the volumes, and it will interactively start Python. So once again, it needs to download it. This time it downloads the Python container. It is official Python container. So we are using the newest container. As you see, it is Python 3.9 release candidate 1, because the 3.9 is still not released. It will be released next month. But for example, you want to show on some conference the newest version of Python, because you are, on the top of everybody. So you can experiment even with my kind of old system. This is system 1604, but I have right now Python version 3.9. This actually, you can see that previously when we started container, it went straight to Jupyter, and right now it went straight to Python. So how does it happen, right? This can be quite important. Why it did that, and for example, how it happened that this blast command was run. So actually, the structure of this command is that docker run. Then you can put multiple flags. So for example, we put the P flag, means port, the V flag meaning volume, the IT flag meaning actually it is I and T flag, so interactive terminal. We put the name of the container, the name of the image. We can put the name of the container, but after the name of the image, if we put something, it will be interpreted that we want to start the software using the container. But if we put nothing after the name of the image, it will go to a default program. And the default program is something that can be different from one image to another. So in case of the Python containers, it is usually a Python console. In case of the Jupyter, it will be the Jupyter notebook. So yeah, right, print hello, right? Let's see, this is an interactive container session. Let's close this session. And we will now go to another command. This is kind of funny command because this command allows us, it is similar to the blast command. This command also uses the Python version 3.90 release candidate 1, but after this command, we have a particular after this the part that was the same previously. And after that, we have that I want to run Python, and I want to run my particular Python program. So this is a program that actually tests the features of Python 3.9. So for example, in the 3.9, you can add two, or you can merge two dictionaries together, and you can see that this is working. So Mystic Mike asked the question, so can I open the container from an image? Yes, you can do that. So you can actually run, you can install a Jupyter inside of this container. I will show you in a minute how you do this. So first, maybe let's start. So let's remove the flag RM. This is a good time to segue into doing something inside of containers. So let's come back to this command. So this command will start interactive Python session, right? Interactive. No, it was actually not interactive Python session because I need to put IT flag. Okay. So right now we have an interactive Python session. But as you may see, inside of this interactive Python session, there is no SciPy and so on, right? It's quite frustrating. But I can access this container through a different console. So in my case, this will be a practical Nordcat, I think. So -IT practical. I am right now inside of this container, and inside of this container, I can install stuff. Maybe something small, requests, maybe small. Right now, I'm installing inside of this container requests. So now I can import requests. BioPython is small. Yes, of course, BioPython would also work. I encourage you to install whatever you need. But as you can see, I installed requests library, and now from this console, I have access to it. So I really forgot how to use it. So let's imagine that you can use it by just using the import requests, right? The main point is that, of course, you can add something to the container. There's actually a good way to do this. This is not recommended this way. So by just, going through Bash, installing stuff, I do not recommend this way. Why? It is because if we want to have a reproducible research, you need to have also documentation. So other people not only need to access your computational environment, but they also need to understand what your computational environment consists of. So there is a better way, and I will show you how. So inside of this container, so this is normally, as you see, it is a root. This is the name of the host name. We can see around. You can also see that there is a My Research directory because we are sharing this, but let's close this. So if I close the exec, it does not stop the container. Just to finish the management of containers from different terminal, I can put docker stop, and I can stop a container. So you don't need to put Control-C here to stop container. You can stop the container from wherever you want. So right now I'm stopping the container. Hopefully it stops. But somehow it takes time. That's interesting. Okay, so we can see that it stopped. And of course, you can automate this and so on. But maybe let's do it later. So what we have now is that we understand that there are containers, there are images. You can do stuff inside of the containers. Actually, there are many cool tricks. For example, you can share your screen inside a container. I will not show it right now because we have only half an hour left with our tutorial, but there is an explanation in the README how can you do that. So you can start a graphical user interface programs inside of the container. Why would you do that? For example, when you want to have also some strange installation procedure. So you have your strange program that requires you to make something and so on. So you can put it inside of the container, even though it is a graphical user interface. You have an example with Genie inside. But now let's go to, let's stop being just a client of the system. And as a researcher, we can create images. So you can create image for other people to use, this template of the computer. And there are two ways to do this. One of these ways is kind of simpler, but I do not recommend this. And the way you do this is, for example, you have this practical Nordcat container, and you can commit this container. Committing means that this container becomes an image. So instead of being just a computer, it becomes a template computer. It's somehow okay. So what happened here is that we created a new computer template, so new image, called new image because I'm not created, that was created from our container. It should be here actually. Okay, so you have Docker image list, and you can see that I created right now a new, actually it is disappointingly large, but I created a new image from container. So coming to the question of, was it Magical Mike? Mystic Mike, sorry, Mystic Mike. Mystic Mike question was whether I can install BioPython and so on. So imagine that you created this Python 3.9 container, you installed BioPython there, and then you want to share your new environment. So to share your new environment, you need to commit this container. You create, for example, BioPython container, and then you can share it, right? But this is really not a recommended way. The recommended way is by using Docker files. What is a Docker file? It is a documented way of creating containers. So documented means that you understand step by step what happened to create this particular image. I created 2 Docker files for you. They are really not super special, but first I need to see whether my screen is there. Okay, so one of this Docker file is called Docker file, and Docker file container, maybe instead of the data science notebook, we will use the Python 3.9. It's kind of cool to use the newest Python. So let's just copy this. It is really quite easy when you look at that. What the Docker file consists of is a set of Docker commands that do some stuff. So first, it is something like import. So from Python, so I start by using this particular image. So like you remember the layers, right? So at the beginning, I start by downloading all of the layers of Python 3.9 image, right? So this is my basic starting point. And then I add my new layers. Actually, normally, each of the lines of this file will be something like a new layer. In my production environment, for example, we have Docker files that have 200 of these lines. And there are also some interesting implications of having Docker files. Because, for example, if I change only one line and I compile this file, the system will just create new layers below the new lines. So all of the lines over the one that I changed will be kept the same. It can be kind of tricky, actually. I will not show you the whole Docker file documentation. You have a couple of commands that you need to know. The first is the from command. The second is run. Run is the same as you would be put something in the console, but there is also copy and add commands and the cmd command. There are many more. In the Docker file cause we will go more into that, but now the basic example. So this basic example is pretty much the same like with the commit example, right? With the commit, I created image, I installed requests, and I committed the new image. So let's recreate this by using Docker file. So I have this Docker file. It is 4 lines long, and to use this, I put Docker build, and now I need to. The most basic form is Docker build and dot. But let's not do this. At least let's put a name for this image by using the tag. So Docker build tag, and this will be requests Python 3. Maybe Python 3.9, and the dot command. Let's put enter, and what happened is pretty much the same what would happen if I all layers.
Read the question.
Okay, so the question from Mystic Mike is kind of strange to me, but I will try to interpret it somehow. Below the line will be recreated, I would say. So the Mystic Mike asked the question of what happens. So maybe to repeat myself, the creation of new layers starts from the beginning of the file. So first, in my file there was from something, so it downloads this. Then it does some stuff. And if I change one of the lines, all of the lines below this will be recreated. So sometimes it is useful, sometimes it is not. Usually you don't need to bother unless you have a really big Docker file. So if you have 200 lines and you change line number 50, lines from 50 to 100 to 200 will be recreated. So it will be a basis to new layers. This is like, I would say, still a simplification. From the point of what we need to know, you can imagine that every line that you change will be redone, and all of the lines below. Okay, so but just for those of you who, for example, receive a Docker file, you can imagine that your friend said to you, "I have this great environment for doing, stuff," and he sends you a Docker file. So to use this Docker file, you just need to put this. There is Docker build. You put the name of this new image, and you put dot. The dot means that the compilation environment is the current directory. So in our case, for example, it is the Docker research. This is like a basis of this. And the Docker file, if you do not put anything here, it defaults to using Docker file named Docker file. So this is quite important that your file name is exactly this Docker file. And as you see, it uses this. We can use this image. So first, let's ensure that this actually was created. So Docker image, was it image ls without this? So Docker image ls, and you can see that there is a new image called request Python 3.9, and it has tag latest. So the tag is something that you put after this. So if I want to put a new tag, I put it after. What is actually the name of this? what is the name of this?
Docker.
Okay, anyway, if you want to put a tag, you just need to put it's not a hyphen. I forgot the name of this, but you put it here. This is tag name. For example, now we'll have two images, one with the tag latest and the other with tag name, right? It is quite important to use these tag names. Anyway, if I want to use this image, I can use the run. So docker run minus IT minus name. What's it name? The name, for example, Python tests. Now I put the name requests Python 3.9. If I do not put a tag name, it will default to the latest. And I think this is all I need. Context consult. That's interesting. There is a Jupyter inside of this. So to give you an explanation, there was the Python, there is the install. Work there means that by default we will start from particular directory, but because previously the executable it was Jupyter, I forgot to change it to Python. So let's just put the Python here. Unfortunately, we have to first build this. And if I want to run, I need now to put the tag name because the latest is a bit different. And again, I need to remove. What was the Python? Okay, no such container. Okay, so right now I have Python 3.9. So let's see whether it is true that it will just recreate a part of the container if I put a new line. So we will put a new line. In this new line, there will be the BioPython. Hopefully it is written like that. Can you show me the chat? The chat. What was the BioPython? I hope it is like that. So I put a BioPython. I will now compile the new Docker file, the new Docker image. No, it is this command. So as you see, it is using cache. So until the requests, it already has all of the layers. And now it is installing the BioPython. From what I see, maybe it is not big, but it is still quite. As I see, it requires NumPy. So this is the blocking point. So during the installation process, let's see the next Docker file. So there will be another Docker file. This is a Docker file called Kausai. Those of you who remember my previous workshop about Bash, this is the most important program in the Linux system. So all of your Dockers should have this program. This is a very important program because it allows you to speak using the cow language. But to install this, it is quite tricky. I tried to install this, and Ubuntu 20.04 system, it installs in a kind of wrong way. So to do this, we need to put an additional command. So let's see what happens. So the from Ubuntu is the same command that we understand. It takes the image called Ubuntu and the tag 2004. Then there is a different command, just a command for the system to know who is the maintainer. Then there is a command that it is kind of similar to the way that you use normal Ubuntu. So normally you would put sudo apt-get update, then you would put sudo apt-get install something and so on. But here you can say that first it is without sudo, because normally you use Docker as a root user, but also you can see there is update. You need to put update, because normally without update you will not be able to install, because actually the system does not remember anything. So believe me that you always have to put update. Then you are installing, but with the flag -y, and you are putting this flag because normally when you install, the installer is asking you something. So for example, are you sure that you want to install? And you need to put yes, right? So you need to put this flag -yes because it is not interactive. This is a command that will be run automatically, so you need to ensure that somebody clicks yes for you. No install recommends, it is something that just does not bloat your software. So Causa is actually quite small program, but if you do not put the this flag, it will install a lot of stuff. And the other part of this command ensures you that after running this command, it removes all of the cache. This makes your container smaller. So, for example, if you want to install something else than Causa, you would be putting something like that. Can install, for example, I don't know, some D, for example, or something like that. This means like go to the next line. But remember that if you want to install something new, it needs to be between update and remove. This is not really required. It just makes your container smaller. This is usually required. But let's remove this. Okay, this environment path, this env, means that inside of your system, each time it is run, the environment variable path will be modified. Normally the path is path, but we will modify the path to path user games. So we add user games to path. I actually experimented with adding another environment variable. So we will also have environment variable cowords. Copy is a way that you put files inside of the container. It is different than the -v flag. So when you have a -v flag, every time you run a container, there is a shared folder with your computer. But when you use a copy flag, when you compile the container, so when you compile the image, it copies a file to the container. So for example, if I run it once, every container that I create will have this file, regardless of whether I, for example, modified this file. Because this, after compiling, this becomes a template, so the image, and from this image I can create 20 containers, and each of these containers will have this what does the Causa file. So this is like a copying inside of the container, right? And the CMD means that if I don't put anything after the name of the image, when I put the Docker container run the name of the image, this will by default start the Causa program. So normally it is Python or something like that, but in case of this container, it will be a Causa. So just to finish the previous one, we have now a container with BioPython. We need to remove the Python tests and start it again. So run interactively Python test request tag name. Okay, import BioPython. I really don't know how to use it, so sorry. Import bio. I hope it works. I really don't know what to expect, but hopefully it works. Anyway, let's start let's compile the second Docker image. So this time Docker build, and we need to put the flag called what is the file? So file is Docker file causa. So we are not using the default name, we are using Docker file causa name, and then we put dot, maybe tag image. Okay. We are now compiling, and you will see the installation process. So first we are updating stuff, then we are importing. You can see here that it is unpacking causa. Okay, and we have now the new Docker program. So cow this, and we will be running cow image. Oh, so let's go. So this is the way that you use Docker files or create Docker files. It is really not super difficult to use Docker files. Maybe you can sometimes by using Docker Hub, for example, when you are on the Docker Hub, sometimes there is here a way to see the Docker file. But if not, you can usually go to somebody's repository. Inside of these repositories, you can see Docker files. And it is quite inspiring. You can see, for example, that here there is a SciPy notebook, and inside of this SciPy notebook, somebody is, for example, using the Conda install. So actually, you can have Anaconda or Conda environments or inside of Docker. Still, it is much lighter. By lighter, I mean easier to use than typical Anaconda system. You can see that somebody is installing all of these libraries for us. It is also enabling widgets for us. It is installing Jupyter Manager. It is doing so much nice stuff just so we don't need. The only, I think, problematic part is that he creates this user NBUID. So somebody really did not understand that after you commit an image, so after you create the image, so if I run this Docker file, the user will be me, right? So Igor. But in case of this guy, inside of this image, his own username was kept there. So kind of unintuitive what he did. Anyway, let's go to the last part of this. This will be kind of short part, but this is more about management. So as you see, there are many different flags that you need to use when you are running a Docker run. So there is actually something like a make file, so make system for Docker. So normally, for example, when you compile something, you put make all or make clean, right? So for Docker, there is something called Docker Compose. Docker Compose is like a lightweight version of Docker management system. There is also not lightweight version of this called Kubernetes, but it is more when you have multiple servers, like physical servers, and on these physical servers you have multiple Dockers. But in case of when you have couple of Dockers, it is nice to still have something like a make system for this. You use a YAML for that, and for example, in this case, I want each time I use this Docker Compose file, there will be two different Dockers starting. One of this Docker systems of these containers will be called research. The other will be called Kausai. And you can see that, for example, in case of starting this first one, we will be. There was a question: what happens when I have multiple Jupyter notebooks, each of them trying to be on the same port, so 888 port. So actually, each of these containers can have a separate port, and I can state it manually. So for example, in this case, this container will not start on the external port 8888, but then there will be mapping. Inside of the container, the port will be 8888, but outside it will be 8889. This is one way. The second way, for example, when you want to start 10 Jupyter servers, you can use kind of like a programmable version of this, because you can see there is maybe on this one there is not, but I can actually in a very easy way start multiple containers in the same time. So just to demonstrate you how to use it, I use Docker Compose app. So first build, maybe Docker compile build. So it built me all of these containers. Then I need to change this because now there is no Jupyter inside. One is the Python, the other does nothing, so sorry for that. Okay, Docker Compose, it has this multiple commands. So Docker Compose build, Docker Compose execute, Docker Compose kill, pull, push, and so on. But the funny thing is that to start this, we don't put run, we use up. Actually, run means different thing. Docker Compose up. What does the Docker Compose up? It starts two containers in the same time. And it should be working. If not in my repository, there will be a workable version of this. The whole point of this is that it is like a way to collect all the flags you want. Also, to give you some more information, for example, you don't need to have only one volume that you share. Regardless whether it is a Docker Compose file or when you start a container by using Docker run, you can have multiple -v flags. This will just mean that you are sharing multiple directories. This is very useful when, for example, you want to share access to your camera. So in case of Linux, it will be like dev and video 0, and I want to put it inside of container as a dev video 0. It would mean that I'm sharing my camera inside of the container, for example. And I also want to share some files and so on. So -p and -v, you can put multiple of these folders and multiple of ports. Sometimes you want to put multiple ports because, for example, your server requires multiple ports. Actually, you can also have like a whole system with the graphics inside of the container that you access through, for example, some video sharing platform, like how it is called, like TeamViewer, for example. You can also do this. But just to wrap up, because we have 5 minutes to the finish of the workshop, I think it is a good time for you to ask some questions. So if you have some questions that I can answer, please ask them now. I will just wrap up the main idea that I'm here to share with you. Docker is a very good way to share your computational environment, create your computational environment, and it is like a lazy way to do this, because there's just a couple of commands. You don't need to. Most of this stuff is being done automatically. So if I want to share my VirtualBox manager, my VirtualBox, I need to export it. I then have to send to somebody like 16 gigabytes file, and he also needs to import it. It takes like half an hour. It is really not worth the hassle. It is also a good way to document what you are doing, and it also has gives you an opportunity to scale your solutions. Scale as well as give other people opportunity to play with your solutions. It is very lightweight. Of course, still, as you can see, the images themselves are not super light. So they are still like a couple of hundred of megabytes or even gigabytes in case of some of these images, but still they are much smaller than actual systems. So you have this computer in the box. The vocabulary is maybe not so easy to understand, because you have these images, you have the containers, you have the hub, and so on. But it is also not super difficult. Also, when you have these images, you are just a couple of clicks away to share them on a Docker Hub. I put it on the repository how to do this. So for those of you interested, to push to Docker Hub, you need to log in. You need to tag your image in a specific way, and then you can push it. On my repository, for example, I think Adohaha on Docker. Using Docker in research, it is already here. That's interesting. But actually, Docker Hub. For example, I put some of Docker files for my students. So I teach about robotics, and it is really a very easy way for students to install software that is otherwise quite difficult to install, actually. So they just need to install this, and they have the system done for them. Sorry that there is a lack of actual explanation of what it is, but yeah, many people do that. In case of reproducible research, I think it is quite obvious for those of you who are enthusiasts of why it can be useful. But even for those of you who are just lazy researchers trying to take less time for the boring task of installing, the recommended way of just finding a Docker image that has all of the software that you want to use already installed is a really good way to do, especially for those of you who are playing with data science, machine learning, computer vision. It is really good way to just use the recommended machines from NVIDIA, from TensorFlow, also from Microsoft, surprisingly. This is it. So do we have any questions? If not, thank you for coming or watching the seminar. I hope that you found it useful. The commands are still on in the README, most of the commands, but I hope it is quite easy to understand. There is a lot of documentation. I also recommend that by just going through tutorials. Maybe as just a last Docker. So if I want to recommend some books, Docker in Action is, I think, the best. If any of you want to learn something, in a more professional manner. But actually, it goes just from what I explained to you, it just goes to have a more scale. So if you want to scale your solutions to multiple computers, or you want to have something, like, for example, you want two containers to connect to each other in so-called microservices. So this is more for professional computers, maybe not scientists, but just programmers or DevOps, because they use the Docker in a bit different way. And you have multiple of these small processes, and you need to connect them together. For example, one container for database, the other for your website. So from like a Flask server, they connect to each other, and the Flask server then connects to the rest of your network. Actually, they don't really need to be on one computer. There is also some details, for example, about how you can set up your own Docker server, so like a Docker hub. This is really for more professional users, and I think for research, this will the stuff I showed you today will make you quite proficient Docker user. So once again, thank you and bye.
Igor, thank you very much for nice workshop. Next week we will have next seminar. Anna Maria, our friend and member of NGS School Society, will conduct a